Hello, in this video we are going to take a look at some definite integrals. So definite integrals, the main difference between definite and indefinite integrals is on a definite integral you have endpoints on your integral sign. So for this one we have the integral from 1 to 3 of the function 5x squared minus 6x plus 7 with respect to x. And what we're going to be using here is the fundamental theorem of calculus part 2. And the fundamental theorem of calculus part 2 says if we have an integral from a to b of some function f of x dx, that is going to be equal to capital F of b minus capital F of a, where f of x, capital F of x, is any antiderivative of lowercase f of x. Another way of saying that is f prime, capital F prime of x, is equal to lowercase f of x. And so the main thing that we're going to look at this is it can be any antiderivative. So all we have to do is find one function that, if we took the derivative of it, would give us what we started with, and then plug in our top number minus our bottom number. Well, that's what we have done in our last couple of sections, and so we need to find an antiderivative for 5x squared minus 6x plus 7, and that is going to be, the antiderivative of 5x squared is going to be 5 times x cubed over 3. The antiderivative of negative 6x is negative 6 times x squared over 2. The antiderivative of 7 is 7x. And then we had been doing a plus c on that. I'll go ahead and put it on this one, and we'll see why we don't have to worry about that any further. And we are restricting this and evaluating this on the interval, so I'm going to draw a vertical line at the end on the interval from 1 to 3, and just keep those numbers in the same order. Alright, so we found this inside the parentheses is our capital F of x, so we're going to plug in 3 minus plug in 1. And so I'm going to go ahead and clean this up as I plug in 5 over 3 is going to be 5/3 times our x value that we're plugging in first is the one on the top, so we've got 3 cubed. 6 divided by 2 is going to be 3 times our x squared plus 7 times 3 plus our c minus, now we're going to do the same thing but plug in x equal 1. So it's going to look just like that. 5/3 times 1 cubed minus 3 times 1 squared plus 7 times 1 plus c. Alright, we can go ahead and simplify this. 3 cubed is 27 times 5/3. Alright, so that'll be 27 divided by 3 is 9 times 5 is 45. And then 3 squared times a negative 3 is negative 27. 7 times 3 is 21 plus c. And then on this one we need to distribute this negative to each of those terms. So we'll get minus 1 cubed is 1, so we'll just have 5/3 for that first term. When we distribute a negative, we're going to get minus a negative 3, so that's going to be plus 3, minus 7, and then minus c. Now, as you see, we've got a plus c and a minus c. Does not matter what c is, those are always going to add to 0. And then if we combine like terms on the rest of it, we get a common denominator of 3 in the denominator, and we get 100/3 or 33.3 repeating. All right, let's look at another example. So here we have the antiderivative definite integral evaluated from 4 to 7 of the function 5x to the negative 2 minus x to the negative 3 with respect to x. So again, we just need to find an antiderivative. And so an antiderivative of 5x to the negative 2 is 5 times x to the negative 1 divided by negative 1 minus x to the negative 2 divided by negative 2. And then since our c's, as we saw in our last example, are always going to add to 0, I'm just going to pick the one where c equals 0. And we're evaluating this from 4 to 7. When you take that antiderivative, your integral sign and your dx go away, and your numbers move from on your integral sign to on this vertical bar here at the end. All right, so if we clean this up, this is going to be I'm going to go ahead and do a step of cleaning up first. So 5 times x to the negative 1 divided by negative 1 is negative 5 over x. And then minus x to the negative 2 over negative 2. That minus and the negative in the bottom is going to make that a plus. 1 over 2x squared. We're still evaluating this from 4 to 7. All right, so if we plug in 7, we get negative 5 over 7 plus 1 over 2 times 7 squared minus, plug in 4, we get negative 5 over 4 plus 1 over 2 times 4 squared. All right, combining like terms in the first set of parentheses, when we add that, we get negative 69 over 98. Our common denominator there is 98. We've got 2 times the 49. And then doing the same thing, getting our common denominator there, our common denominator is going to be 32. And we get a negative 39 over 32. Don't forget we are subtracting these. So when we do actually subtract those, this one doesn't end up being really nice as far as a percentage, or as a fraction, I mean. We get 807 over our common denominator there is 1,568, or as a decimal, that is approximately 0.5147. All right, I'll see you guys next time.